3, I will take classes for module 2 and module 4. Now you don't have to worry regarding exams and all. The questions will be not be very difficult. So whatever I teach in class or questions will be something around that only. The subject is a bit not difficult. It requires practice. One thing I make you sure that the subject only requires practice, practice, and practice. Okay, it is not at all difficult. If you practice very well, questions will be easily solved. The main thing is that you have to solve various types of numericals, various types of questions, and you have to be time efficient. Okay, because I have seen in offline, obviously in offline we face a lot of problems. Students face a lot of problems, but in online also, to sum up, to solve all the questions step by step within 3 hours and submitting the answer script within 3 hours is very difficult. Okay, so you have to be time efficient, and time management is very important for this subject. Also, there are other subjects like RCC which requires time management. Now, another important things to tell you that for the diagram part, I will share in the PPT. While while solving the numericals and all, you have to be ready with your pen, pencil, and copy and calculator. All of you should be ready with that. And we have a Google Classroom. If notes are required, I will upload there, obviously. And recording of every class is done. So at the end of every class, maybe for example, I take the class in the morning. So after 5 to 6 hours, the recording is received by mail in the email ID. So I will mail you the recording email ID each and every day. Okay. If I forget to mail, please make sure if I forget to mail the recording, please call me up or WhatsApp me in the group. Okay. So welcome to the analysis of structures 2. In the module 2, we will learn the first chapter. A module 2 consists of 3 important topics. That is, first is the unsymmetrical bending of beams, which I am sharing it. You can see unsymmetrical bending of beams. Another topic is there, uh, that is the curved beams, curved bar, the design of curved bar. Okay, so these two are the important topics which are in module 2. Main is the unsymmetrical bending of beams. So from the word, you can see that whatever we have learned previously in strength of materials or structure analysis 1, we have used well-known simple flexural equation or bending equation, simple, to in order to analyze or in order to find out the bending in beams. We have understood that it is a symmetrical bending. That means the bending equation m by I sigma by y equals to E by R, it is applicable for the cross section of a beam. Whatever the cross section may be, it may be I section, T section, rectangular section. This m by I equals sigma by y equals to E by R. This equation we use for to calculate the bending moment, as well as first we calculate the bending moment m, and based on this bending moment, if we know the geometric properties like Young's modulus, radius of curvature, then moment of inertia, if we knew all these things, the geometric properties, then we can calculate the bending stress. So first we have learned bending moment m, and based on the maximum bending moment, we calculate the maximum bending stress according to bending equation, which we have learned till date. This is the normal condition. Okay, that means what is the assumption? The assumption that the neutral is here. What is the assumption is lying behind this? That is, the neutral axis of the cross section of the beam is perpendicular to the plane of loading. The neutral axis of the cross section of beam is perpendicular plane of loading. I will express this in the whiteboard also. So these are the theoretical parts. Theory will not come in exam. Okay. So this condition very important. If you see the second point, that means if we have the rectangular beam, then at the neutral axis, so the neutral axis passes through the mid section of the cross section, and we will see that the neutral axis, if is horizontal, then vertically, transversely, the loading is acting. So in this condition, the bending equation is applicable. And when this bending equation is applicable, it is known as symmetrical bending. That is which normally we have learned till date is symmetrical bending. See the second point, this condition implies that the plane of loading or plane of bending, see the plane of loading or plane of bending is coincident with or parallel to a plane containing principal centroidal axis. Okay, that means it is assumed that in symmetrical bending, the plane of loading, I will show you in the whiteboard. This is the theoretical part. The plane of loading, the plane at which the loading is taking place, the vertical loading or transverse loading. Here we are not interested for horizontal load. We are only interested for vertical. So the plane of loading or plane of bending is either matching with x-axis and y-y axis, either they're matching or they're parallel to x-axis and y-y axis. Okay, so this is the main assumption for symmetrical bending. Okay, the plane of loading, please, the theory I will not write in the board. I will solve. I will show you the diagram in the whiteboard. Okay. So second important point, that is plane of loading or plane of bending is parallel to or coincident with the principal centroidal axis. What are the principal centroidal axis? We have x-axis and we have y-y. Main principal axis. Dutoই আছে. Okay. So this is the diagram which we have learned in strength of materials. That is due to transverse loading or vertical loading, the beam is subject to, the beam may be simple supported beam, cantilever beam, whatever beam. So this beam is subject to bending, transverse bending. Bending is also known as flexure or bending. Both are same name. Since beams undergo bending, since beams undergo flexure, beam is also known as a flexural member. Okay, this you will learn in RCC. That is for columns. Columns, it is subjected to axial forces. It is subject to compressive forces. So column is known as compressive member. Beams is undergoes bending like this. It is flexure or bending. It is called flexural member. See here, I have discussed. I have written the what is the main theme of symmetrical bending. So see, it is SC did this. It is essential that the plane containing one of the principal axes of inertia, that is x-axis or y-y, the plane of applied moment and the plane of deflection should coincide. Very important. This all this PPT I will upload in the Google Classroom. Please make notes in your copy because MCQ will come. MCQ can come from theory. That's all. So the plane containing principal axis of inertia, the plane of applied moment and principal plane of deflection should coincide. Another thing, see here this point, the neutral axis should coincide with the principal axis of inertia. That is an important criteria for symmetrical bending. So if we, this is a basic theme of moment of inertia. If we calculate I-axis, so that there are two principal axes. If you see, we have I-axis and we have I-y-y. So I-axis, the principal moment of inertia about x-axis, and I-y-y, principal moment of inertia about y-y axis. So this is the beginning. This was the for deriving the moment of inertia, which we have learned in second year. This was a fundamental equation, but we hardly use this equation. Okay. Now we have another. So we have I-x-x, the moment of inertia about x-x axis, I-y-y, moment of inertia about y-y axis, and another is product of moment of inertia. See, product of moment of inertia. See, I-x-y. So the above integral is called product of moment of inertia. Okay. So if you take a small elementary, very infinitesimal body, very small body of area dA. Okay. So this area, this small area, it is located at some x distance from y-y axis and y distance from x-x axis. Okay. So this is the thing. But I-x-y, that is the product of moment of inertia, is while calculating for problems numerical, it is slightly different. When you will solve the problem, then you will understand. Now, coming to unsymmetrical bending of beams. Now, first, let us learn why we are learning this unsymmetrical bending of beams. Unsymmetrical bending of beams. Unsymmetrical bending of beams is basically applicable in steel structures. Always remember, unsymmetrical bending we consider in case of steel structure, where, for example, we have I section or any section. We have rectangular I section, T section, which is located in trusses. Mainly for trusses, if you see the trusses where the members, we have purlin, we have rafters. So, okay. So, in case of trusses, what happens? Due to application of various load combination, that is dead load, live load, wind load, which comes at any angle. So, see, the loads are coming at a very distorted way, not vertical, not horizontal, but at an angle. So primarily, unsymmetrical bending mainly takes place is very much important in design of steel structure. Okay. So what happens? Why, sir? Why it is applicable in design of steel structure? Very important. This unsymmetrical bending is rarely observed in RCC members. Okay. Now, if the column or beam is inclined, then then it can be subject to unsymmetrical bending. But mainly in steel structures, where the steel structures deform in a very peculiar manner, like these joints. At these joints, what happens? We provide I section or T section members in inclined position, like this. See here, inclined position. It is I section, right? I section, T section. We have angle section also, like this. So if you see, you will learn in the 6th semester. So this is called channel section. Channel section. Okay. Then we have angle section like this. Right. So whenever these sections, they are inclined place, they're placed inclined in nature. Okay. So in these cases, the unsymmetrical, either they are placed inclined or the loading is coming inclined. The member is straight, but the loading is coming inclined. Then also unsymmetrical bending of beams takes place. Okay. So coming to the thing. Okay. So before coming to the statement, okay, let me show you. So let us learn this thing, then we will come to the board. So unsymmetrical bending, see here, what is the statement? If, however, the plane of loading or plane of bending, I told you for symmetrical bending, that is a plane of loading or plane of bending, either is parallel or coincident with the x and y axis. But in unsymmetrical bending, what is happening? Just the opposite. That is, the plane of loading or the plane of bending does not lie in parallel to a plane that contains principal centroidal axis of the cross section. Then the bending is called unsymmetrical bending. What happens? Another point, in this case, the direction of neutral axis is not perpendicular to the plane of bending. The direction of neutral axis is not perpendicular to the plane of bending. Okay. So that is the thing. Now, let me come to the whiteboard. Let us learn the two statements. That is the reasons for unsymmetrical bending. Reasons for unsymmetrical bending, there are two criteria where unsymmetrical bending can take place. Very, very important as far as is concerned. MCQ. First is the section is symmetrical. See here, the section is symmetrical, but the load line is inclined to the principal axis. The section is symmetrical. That is, we have symmetry with respect to x axis and y axis. The section is symmetrical, but the load line is inclined to the principal axis. The load is inclined. Or the second criteria, the section itself is unsymmetrical. Symmetrical section means, for example, you take normal I section. If you see here, normal I section, left side, it is symmetrical section because the top, this is the flange flange, and this is the web. Okay, so it is all the dimensions of flanges are same, so it is symmetrical section. If you take a rectangular section, simple rectangle, square section, circle, all these are symmetrical. But unsymmetrical section like this: angle section, channel section, C shape, channel section, T section, T section, all these sections are unsymmetrical I section, where the top and bottom flanges are not same. So in all these cases, when the sections are unsymmetrical, then we can see the second point. If the section is unsymmetrical and the load line is along the centroidal axis, that means the load is falling along x-axis and y-y, but the section is unsymmetrical. Then unsymmetrical bending takes place. So two important cases, that is the section is symmetrical, the section is okay, but the load is coming inclined, then unsymmetrical bending will take place. Or the section is unsymmetrical, like angle section, channel section, and the load line is along any centroidal axis. Okay, so these are the reasons. We will come to these diagrams later on. So these are the main criteria for unsymmetrical bending of beams. Okay, now this chapter demands the basic idea to find out moment of inertia. Okay, so let us come to the white. Again, if required, I will come to the PPT. Just wait. Okay. It is very, very difficult to take online class also nowadays. Okay, is the board visible? Board visible, so?
Yes.
Sometimes when I will ask you, you have to respond. Okay. So coming to this thing, unsymmetrical bending of beam. So unsymmetrical bending of beams. So we started, as I told you, that what is the, so there are two cases, symmetrical and unsymmetrical. I talked about the statements. Okay, now I will show you in the figure how it is applicable, or what is the physical significance. Okay. Whatever I have discussed to, that is in the statement form. Symmetrical and unsymmetrical bending. Symmetrical and unsymmetrical. Okay. Now, what is happening? For example, I told you that is the loading is acting transversely in this direction. For example, I have UDL or point load, something like this. Any sort of loading is there, and this loading is vertical loading, or you can say transverse loading. Okay. And I told you this is the neutral axis. For example, what is neutral axis? Neutral axis is the layer of fiber where the compressive stress and tensile stress is zero. You know, that is compressive stress and tensile stress is zero. It is the location. Okay. So compressive stress and tensile stress zero, so neutral axis. So basically, so that is the thing. That is the neutral axis is either the neutral axis lies or the neutral axis is perpendicular. First statement, the neutral axis is perpendicular to the loading, right? Second thing, that is the plane of loading. See, the plane of loading, plane is a plane. The plane of loading is parallel. For example, it is x axis and it is y axis. So y x. Okay. So the plane of loading is parallel to this plane of loading is parallel to or coincident, means it is matching with this axis. That is, the plane of loading is parallel to x axis here. For example, I have a beam like this and I have a loading like this. Then what is happening? This plane is parallel to y axis. So the plane of loading here in the plane of loading is parallel to x axis, and here the loading is parallel to y axis. So in unsymmetrical bending, the plane of loading is either coincident, either matching completely, or parallel to x and y axis. So x axis and y axis are principal centroidal axis. See here, right? Very important. In normal case, it is a principal centroidal axis. Principal centroidal axis. Principal centroidal axis. Principal centroidal axis. Okay. Now, so IXX, if someone asks me how to find out IXX and IYY, so we use the principle of perpendicular or parallel axis theory. Parallel or perpendicular axis. Parallel or perpendicular axis theory. Perpendicular axis theory, right? Okay. And what is IXY? IXY is product of principal moment of inertia. Product of principal moment of. If someone tell Ayush Roy to not to join, because I will not allow him. Okay. So IXX is the principal moment of inertia about x axis. IYY principal moment of inertia about y axis. Okay. IXY product of moment of inertia. Okay. So these are the basic things which we have learned in symmetrical bending. So now how in come to this side again. So how we used to find out for principal for parallel axis theorem. For example, this is my x and y axis, and for example, I have a body. Okay, any body. For example, this. For example, if I have normal, if I have compound body means which consists of two different bodies. It is attachment or it is superposition of two different bodies. Okay. Now, for example, I have a body. Okay. Now, with respect to this, so this area I told you, the location with respect to y axis, let us take x, and location with respect to y axis, let us take y. For example, distance. Okay. Central. So what is big IXX? For example, this body is rectangle. Body is rectangular. Let me take B. Width of the body B and depth is G. Okay. Let me take simple part. Okay. Let me take simple part. So what will be this moment of inertia with respect to x axis? Now see, only calculating the moment of inertia of a single body. That means just a rectangle or triangle or circle. All these for calculating the moment of inertia for simple diagrams are given in the chart. In strength of material books, you can find out. That is, for rectangular or circular or triangular, only singular body moment of inertia is given. But if you have compound body, that means a combination of rectangle, two rectangles, three rectangles like this, then we have to apply parallel axis theorem. Mainly we apply parallel axis theorem. It is easy to apply. Okay. That is why we apply parallel axis theorem. So what will be the formula for parallel axis theorem with respect to x axis, because we are calculating moment of inertia about x. So it is b with d is the depth. So the what will be the normal? So the basic formula is normal moment of inertia about xx plus area into distance square. Area into distance square. Okay. That means for example, I have, let me take, I have this body, and this body, like this. So I have three different rectangles. So what will be my thing? So the moment of inertia of one particular body will be the moment of inertia of individual body plus the area multiplied with this one, x1 y. So area plus area into the centroidal distance between the centroidal distance square. Okay. So this will be for ixx, and similarly for iyy, this will be moment of inertia on y axis plus a into y square. So please remember this, everyone knows, but the second term everyone feels difficult. Please make moment of inertia with respect to any axis. So area multiplied with the distance between the CG. Okay. So here x bar, that means from x distance. So if you want to find out Iyy, that is the original moment of inertia of the body plus area multiplied with the distance between two CGs, CG of the whole body and CG of the individual body. So when I will do the problem, you will better understand.
Sir, both visible na ঠিকঠাক?
হ্যাঁ স্যার, 1 মিনিট একটু ওয়েট করা
যথেষ্ট
হবে?
ভিজিবল। আমি ল্যাপটপ, হ্যাঁ হ্যাঁ, যখন নেট ডিস্টার্ব করবে আমাকে বলে দেবে। এখন ভিজিবল আছে?
হ্যাঁ স্যার, ঠিক আছে এবার।
হ্যাঁ স্যার, ঠিক আছে।
ওই মাঝে মাঝে প্রবলেম হলো, অসুবিধা নেই, আমি রেকর্ডিং করছি, তো রেকর্ডিং একটু দেখে, ঠিক আছে? তো IXX and IYY, এবার রেক্ট্যাঙ্গুলার ক্ষেত্রে এটা কি হবে? দ্য বেসিক ইকুয়েশন, দ্য বেসিক মোমেন্ট অফ ইনার্শিয়া ফর রেক্ট্যাঙ্গেল BD cube by 12. So please everyone make sure at least remember three bending moment, three moment of inertia. First is moment of inertia of rectangle, circle and triangle. Okay, three basic figures you have to remember for lifelong. So BD cube by 12, this one, that is, so if I have, for example, this one, this body, or let me take a rectangle. So it is x axis. So moment of inertia about x axis, so B into d cube, by 12. If I make it along y axis, the B will become D into the y axis. So x axis is horizontal, to B into d cube by 12. When you would take about y axis, B becomes, because y axis is perpendicular, so just change your face. So B becomes D, D becomes D. So dB cube by 12. This is the basic, the moment of inertia of individual bodies. Okay, individual bodies. Always remember. So this is how we find out IXX, IYY, and how to find out IXY. This I will show. So these are the things which we have learned in symmetrical bending. Now coming to unsymmetrical. In unsymmetrical bending, I already told you. In unsymmetrical bending, I already told you that the plane of loading does not coincide, right? The plane of loading does not coincide. So, for example, if you have a body like this, I have an inclined plane and I have a body like this. Okay, inclined plane, body like this. So, what will happen? X and y. So, these are x and y, the principal axis. Now, two things can occur. Either the body is symmetrical and the loading is applied at an inclined angle. For example, load is applied at some theta dash, some angle theta. Okay, this is one case. The body is symmetrical, even if the body is inclined, no problem. The body is inclined, or you can say the body is straight. The body is lying horizontal. Then also, if the loading is inclined, we will have unsymmetrical bending, or you have the body is not symmetrical like this, angle set, angle set. Then also, for example, the bodies along this direction, the body is either parallel or coincident with x and y axis also. Due to this symmetry is unsymmetrical about x and y, no symmetry. Then it will undergo unsymmetrical bending. Similarly, if you take channel section, y and x, it is having symmetry about x axis, but is it having symmetry about y axis? No, it is symmetrical about, so it is a mirror image about x axis, not about y axis, right? So it will undergo, so whatever the loading, it will undergo unsymmetrical bending, right? It will undergo unsymmetrical bending. So two important cases: the body is symmetrical, load line is inclined, or the body is unsymmetrical, load line is parallel or coincident in the two principal axes, x and y. Okay. So this is the difference between symmetrical and unsymmetrical, and also in unsymmetrical case, the neutral axis is not parallel to the plane of load. The neutral axis is not parallel to the plane of load. Okay. So this is a fundamental thing. Now, another important thing, that is coming to the unsymmetrical bending of beam. So these things I have told you in statement. When we will solve the numericals, then only you will better understand. Now let us consider I'm sharing the screen. Now see what is happening in this particular diagram. I'm sharing here. Yes. So you can see in the unsymmetrical, this is a practical. This does. So if you are not able to see the screen, just pin on the screen. Okay. If you pin, there's a pin option. Pin symbol is there. Just pin that, and the sharing screen will be largely coming. Okay. In your laptop or in your whatever electronic gadget. So in the unsymmetrical bending of beams, what is happening? I am taking an arbitrary body. This is normally just an arbitrary body. It can be rectangular, T section, I section, any shape, no problem. Okay. So now we have two main axes. You can see the diagram. If you feel, you can draw the diagram also, no problem. So x and y axis we have. Now these x and y axis, they are the originally principal axis. It will always remain standard, no problem. Okay. But now since the symmetrical, the bending is unsymmetrical, we have we have a set of two new axes. That means since if you check the diagram here, the x-axis and y-y, the x-axis axis have taken turn or are converted into a new axis, that is UU. Thus, I have to give a name. That is why the x-axis axis have inclined at some angle theta due to unsymmetrical loading or due to the unsymmetrical cross section. The x-axis axis have turned into UU. You can see in the diagram, and y-y axis have turned into VV. VV. Okay. So this is the important thing, that due to unsymmetrical bending of beams, in unsymmetrical bending of beams, a set of two new orthogonal mutually perpendicular axes are developed. Okay, that is the most important thing, the fundamental difference between x-axis and y-y axis, or the fundamental difference between symmetrical and unsymmetrical. So x-axis axis converts into UU, and VV axis, y-y axis converts into VV. So the angle, the axes are inclined at some angle theta. Okay, you can see that they are inclined to some angle theta. Please take this diagram down, and if you see in the diagram, there is a point P also. Let me make it. There is a point P which is located within a body. Okay, so I have demarcated a point P which is located within a body, having coordinate U and coordinate V. Now, initially, if it was symmetrical bending, then the coordinate would have been x and y coordinate, just like Cartesian coordinate, x and y graph paper. But here, x and y have converted to u and v. Have you understood, all of you, this diagram? Because if you understand the diagram properly, then only you will be able to solve the problems. Yes or no?
Yes, sir.
Yes, sir. Yes, sir. স্যার
So all of
বলছিলাম
you,
এই আয়ুষের
all of you,
স্যার স্যার বলছি আয়ুষের ফোনটা খারাপ হয়েছিল, তো ও অনেকক্ষণ ধরে মেসেজ করেছিল গ্রুপে যে জয়েন করার জন্য।
হ্যাঁ হ্যাঁ, তো ওই 9:20 যদি জয়েন করে, আমি কি জয়েন করতে পারবো? দেখো, তোমরাও তো কষ্ট করে জয়েন করছো ক্লাস, তোমরা ওর পার্থক্যটা কি হচ্ছে, তাই না? ইউ হ্যাভ টু হ্যাভ আ ভেরি স্ট্রং ইন্টারনেট, ঠিক আছে, ফার্স্ট টাইম।
স্যার
আমার কোনো অসুবিধা নেই। হ্যাঁ, বলো বলো বৃষ্টি, বলো।
স্যার বলছি এটা, হ্যাঁ প্রশ্ন আছে। বলছি যে স্যার আমরা ডায়াগ্রামটাতে দেখতে পাচ্ছি যে ভি আর
জাস্ট ওয়েট আ মিনিট। হ্যাঁ বলো, সরি, ফোন কল।
ইয়েস স্যার, আমি বলছি যে ডায়াগ্রামটা উপরে দেখছি যে আমরা ভি আর ওয়াই অ্যাক্সিস এর মধ্যে অ্যাঙ্গেলটা থিটা মার্ক করা আছে, বিকজ এটা অ্যাঙ্গেল, কিন্তু নিচের দিকে দেখাচ্ছে যে ভি আর ইউ এর মধ্যে একটা থিটা অ্যাঙ্গেল মার্ক করা আছে স্যার, সেটা তো 90 ডিগ্রি হওয়ার কথা।
না, ভি আর ইউ না, ওটা হচ্ছে, দেখো, ভি আর এক্স এর সঙ্গেই আছে। সি ইন দ্য নিচে, উপরে আছে ওয়াই এর সঙ্গে ভি, আর এখানে ওয়াই এর সঙ্গে ভি। তো তাহলে এখানে একটু অ্যাঙ্গেলটা ভুল দেওয়া আছে। This angle, if you see, this angle is
ওকে
wrongly
ওকে,
given.
আচ্ছা আচ্ছা,
It should be with x and u. Okay. Thank you. This absolutely
ওকে স্যার,
correct.
ওকে।
This angle theta will be with x and u. Obviously the angle will be calculated anti-clockwise. Very important. That is most important thing. And this angle theta should be between x and u or y and vv. Okay. Y and vv.
ওকে স্যার।
ঠিক বলছি, it should not be between, yeah, because the angle between UU and VV axis is always 90 degrees, because they are mutually perpendicular. Okay. So we will get two sets. So please draw this diagram. And after this, আমাদের দুটো equations আছে. Here in this chapter, we have to learn 6 equations. তাহলে আমাদের অঙ্কগুলো হয়ে যাবে। So due to unsymmetrical bending, we have the x and y, the original principal coordinates, they have turned to take a new axis, that is VV and UU. আমি বলে দিচ্ছি, that is the transformation of axis. আমরা polar coordinates বা polar mathematics শিখেছিলাম class 12 এ। So using that polar coordinates of polar geometry, which we have learned in class 11 and 12, so from that we will be able to find out the coordinates of U and V. Okay, so this is a particular diagram, and we have a point P which is located within this body, because after this finding out after finding out this principal moment of inertia, we will be interested to find out the deflection or the maximum bending moment acting at this point P. Okay, so please all of you take this down. So those who want to see the diagram, you can pin the screen, and when you have all copied, I will stop sharing. Okay, if I stop sharing, then only my screen will be visible. So I think all of you have taken down this diagram very quickly. Now with respect to this, I will write two equations. That is, now see here it is IXX and IYY, it was previously. Now we have a set of two new equations, that is IUU and IVV. That is moment of inertia about UU axis, moment of inertia about VV axis. Okay. So all of you taken down. So let me stop sharing. Okay. So now due to, please write down, if you feel, due to unsymmetrical bending, due to unsymmetrical, two original principal coordinates, sorry, two original, this word is basically in this not in, if you check the book, original word is not there, but for your understanding I am making you write down. Okay, so just wait a minute, let me. Yes, so the two original, please everyone make sure the West Bengal government have given announced that college will open, but we are not sure. Even I have talked with many of the faculty members in the college or outside college. We don't know actually what will happen. We are not sure. So please, whatever, in any form, whenever the class will take place, please do not miss the class. Okay, so properly do at least my class. Okay, so two original principal axes, that is xx and yy, they are converted to, xx is converted to uu and yy is converted to v at angle theta. The angle theta is anti-clockwise. It is calculated anti-clockwise. Okay, the calculated anti-clockwise. All of you make sure before 9:10 every day, whenever class will take place on Wednesday, before 9:15, please make all your Wi-Fi devices, electronic gadgets proper. Because when I start my lecture class, I feel very disturbed. Okay, because there is a flow which very important. In online class, I cannot see you, but you cannot see me. You can see me, so I'm not able to communicate with all of you. That's a very big problem. So xx is converts to uu, so therefore we can write IXX has turned into IUU and IYY has converted to IVV. Okay, IVV. So what is the formula for? So new principal moment of inertia. So new principal moment of inertia. What is that? So what is equation? IUU. Please write down. So previously, first, what we have to know? We have to know for a particular body, whether it is symmetrical or unsymmetrical body, we have to calculate IXX and IYY first. Okay, we have to calculate IXX and IYY. I will tell you when I will solve a problem. Step by step, we will solve the problem. Okay. Kokono, do not forget or do not just think that, oh my God, this is a huge problem we have to solve. No. Always divide a large problem into stepwise. This will help you to excel in exam. Okay. So principal moment of inertia IUU will be, so I told you we have to know IXX and IY. So the equation of IUU will be, it is somewhat similar. This equation, please make sure this equation is somewhat similar to, have you learned principal stress strain in strength of materials? Yes or no?
Yes, sir.
Yes, sir.
Yes,
These
sir.
equations are somewhat similar. The pattern is somewhat similar to principal stress strain. Okay. So IU is IXX plus IYY by 2. Make it write down. IXX plus IYY by 2 minus root over of IYY minus IXX by 2 whole square. IXX plus IYY by 2 minus root over of IYY minus IXX by 2 whole square plus IXY square. IXX plus IYY by 2 minus root over of IYY minus IXX by 2 whole square plus IXY square. That IXY is the product of moment of inertia. IXX and IYY, for example, if I say the moment of inertia of XX is greater than moment of inertia of YY, then IXX will be major axis. Okay, major axis, minor axis. If this happens, if, for example, if the moment of inertia about XX is more than moment of inertia of YY, then IXX is the major axis, YY is the minor axis. But it can also happen the vice versa, no problem. But this formula we have to remember. Okay. The first is minus, and for IVV, similarly, so this is the first equation IVV. Then we have another equation IVV. The whole equation remains same. There's a minus turns into plus. So IXX plus IYY by 2 plus root over of IYY minus IXX by 2 whole square plus IXY square plus IXY square. Now these are the two equations. That's the two new principal moment of inertia. Achha. If you are, one thing very important, you can remember just only one equation. Why? There's a trick. Please make sure. Instead of remembering two big formulas, you can remember any one of the equation, because there is a trick for this. Dharma, write down. Trick. The trick is, for any for any symmetrical, the trick is for any symmetrical or unsymmetrical bending, trick is for any symmetrical or unsymmetrical bending, the sum of two mutually perpendicular principal axes for any symmetrical or unsymmetrical body, IXS plus IYY, that is the sum of two IXS IYY are like mutually perpendicular. So the sum, please write down the sum of two mutually perpendicular moment of inertia, or the sum of the moment of inertia about two mutually perpendicular axes is always constant. Is always constant. So IXS plus IYY will be equals to the sum should always be same. The sum, this equation will always the constant universally truth. It's always true. So IXX plus IYY will be equals to IUU plus IGB. Very, very important. If you remember one equation for IUU, if for example, we know IXX, we have to calculate IXX and IYY by default, right? So this we have to equate. Now, if you know only one equation, the other unknown will be available. Okay. If you just remember one equation, the other will be available. So you don't have to remember two equations. So these are three. Okay. Another trick that is there, the tricks are there very important regarding this thing. That is, please remember for a symmetrical member, for symmetrical member, but not symmetrical, let me write down this way. Very important, that is for any compound members. Compound member means there are more than one number, there are more than one diagram. For any compound member, write down for any individual symmetrical member. For any individual symmetrical member, কি হচ্ছে না, the moment of inertia about xx will be equals to the moment of inertia about y axis. Just wait because it is turning hazy. Yes. So for any individual symmetrical member, for example, rectangular section or circular section, the moment of inertia about xx will always be equals to yy, and also the CG distance, that is CG distance about xx axis will be equals to the CG distance about y. Cxx and cyy are the centroidal distance. Right? For any symmetrical member, okay. For a symmetrical member, IXX and IYY will be same, and the centroidal distance will be same. This is obviously for symmetrical. For individual symmetrical, please erase the symmetrical, right? For any individual or for any equal angle section, please write down for any equal angle section. For any equal angle section, this is applicable. For any equal angle section, IXX equals to IYY and CXX equals to CY. Equal angle section meaning if we have this, it is an angle shape, this L shape, okay? So this is for these are the legs of angle section. They are known as legs of angle section. So if these lengths are same, L1, L2, okay, L1, L2. Now if this L1, L2, these are the legs, the edges are same. If the edges are same, then it is, if the edges are same, then it will have equal angle section. If they are not same, it is called unequal angle section. If L1 not equals to L2, it is called unequal angle section. Unequal angle section. Okay.
Sir, can you repeat that thing again because the voice is breaking?
Yeah. I know. Because the net is also very unstable. I can see this also. Yes. Just a minute. একটু ঠিক হয়ে যাক. Sometimes this is the main problem in online class. Sometimes the net becomes very fluctuating. I can see I have connected to laptop and cell phone both. So I can see in the laptop it is fluctuating. So see here. Now is it possible? It is audible. See what I want to tell that is this is an angle section. This is, if you see the angle, it is L section. It is known as angle section. Or if we have this channel section, C section. C section here, there also called. It is the extension of angle section. C section. So if the sides, if the length, if the dimensions of the length are same, it is called equal angle section. This equal angle section. And for equal angles, this is applicable. This is a shortcut. This is a trick. This will save you time. You don't have to separately calculate IXX, IYY, or you don't have to calculate the CG distance with respect to XX axis and YY axis. So these are the tricks. It will save you time. For the equal angle section, if the sides are same, it is equal angle section. If the sides are different, it is called unequal angle section. You will get numericals on this. Okay. Have you understood, all of you? Now,
Sir.
there is another, that is, so coming to the, again I will come to the PPT because I will show the diagram. So these are the basic equations. So whenever I will tell you, whenever we will solve problems, we have to follow first this thing. Okay. So now the same diagram I'm sharing again. Now the first thing is the basic thing which we have learned, that is calculation of IUU and IVV. That is the new set of principal moment of inertia. Okay. Now the second stage is we are interested to find out the bending stresses. We are interested to find out the bending stresses at this point P. We can see this point P. You can see this point P. So we are interested to, on this diagram particularly, we are interested to calculate the bending stress of this point P. Okay. So that is this is the diagram for this, if we are interested to find out the bending stress. Okay. So please draw this diagram, the similar diagram here. We have the bending moment. Please draw this diagram, then I will explain what is happening in the diagram. To draw this diagram, it is this diagram. You can give the heading, that is calculation of bending stress inside a point of unsymmetrical bending. So the same diagram, it is now, it is subject to maximum bending. This one. Maximum bending moment. Okay. So we are interested to find out this maximum bending moment at this point P, which has coordinates U and V. So now I will tell you what are the coordinates of this point U and V, because it is not X and Y now. So it is U and V, and if you see the maximum bending moment is coming along YY axis. For example, the loading is vertical. The loading is vertically coming. The loading is transverse. The maximum bending moment, for example, the maximum bending moment is the M. It is acting along the axis YY. So now in this unsymmetrical bending case, so it is not symmetrical. So if this bending had been symmetrical, then we would have applied basic bending equation. M by I, E by Y equals to sigma by R, or M by I equals sigma by Y equals to E by R. But here, this moment have converted or taken into two different components. If you see the bending moment, it has two different components. If the angle of inclination is theta, then along VV axis it is coming m cos theta, and along UU axis it is coming m sin theta. Okay, so this bending moment have taken two different components. Okay, and we have to consider these two components of moment in order to calculate the maximum bending stress at this point P. In questions we will come to questions where we have to calculate the at various points are there. For example, on a point there are, on a body there are 3 different points or 5 different points. We will be asked to calculate the different bending stresses at different points. Okay, so this is the concept. So the bending moment has converted into two different components. And this angle alpha, what is angle alpha? Quite obviously, this angle alpha is the location of neutral axis. You see, particularly see the diagram. This dotted line is NA, neutral axis. The angle alpha is the, if someone asks you to find out the location of angle alpha or the location of neutral axis, then angle alpha is inclined with respect to UU axis. Okay. Neutral axis inclined at angle alpha with UU axis. All of you take this down, and obviously the point G, you see this point G is the point of CG. Point G is the point of CG where all the axes are meeting. Here we will assume that the XX, YY, UU and VV, all these axes, they are meeting at one singular point, that is CG. That means that even if the beam is subjected to unsymmetrical bending, the location or the position of CG is not distorted. Because if the distance or the location of CG gets distorted, then the body will itself becomes unstable. Okay, so please make sure this thing. So the bending moment have taken two components, m cos theta and m sin theta. If you see here, we have discussed here. Let us determine the stress distribution over the section. So the moment in the plane UU, if you see here, along UU axis it is m sin theta. See, the moment in the plane U is m sin theta, and moment along plane VV is m cos theta. So this you can write, the moment along the plane U is m sin theta, and moment along plane VV is m cos theta, where theta is the angle of inclination. So finally, the equation for the resulting bending stress at point P is given as sigma B, that is bending stress, m sin theta into U by IVV plus m cos theta into V by IU. Sigma B, if we just write on the last equation, that is the bending stress at any point is m, that is the maximum bending moment. You can take this maximum bending moment, you can take common. Okay, is common. So m u sin theta by IVV plus v cos theta by IU. So here you need the maximum bending moment calculation, you need the angle of inclination, the two principal axes, and the coordinates of u and v. See, the coordinates of u and v. So obviously, if someone tells you that what will be the bending stress at this neutral axis, what will be bending stress on this neutral axis, then the bending stress will be 0. So at the bending stress at this line will be 0. And other than neutral axis, the bending stress will be have some value. Okay, so this is the equation. Are you writing it down, all of you? Please write it down. The bending stress is at point P. So here we need the maximum bending moment M and the coordinates of U and V and the other parameters. So finally, to take yes, this equation, there are a lot of things written. So if someone asks you, you have to find out the location of neutral axis. The last equation, the red line, the location of neutral axis, that is tan alpha equals to minus IUU by IVV into tan theta. Tan alpha equals to IUU minus of IUU by IVV into tan. That is the location. This thing is this equation which signifies is helpful to find out the location of the neutral axis. So these equations will be used to find out. Okay, so tan alpha, the location of neutral axis, this equation, and the bending stress equation, bending stress at point P. Please write these formulas because this will be helpful for your problem, numerical. All of you written down, please comment or
Yes, sir.
just
Done.
respond.
Yes, sir.
So now coming to the first problem, this problem, the first type of problem. The diagram is there. I will show the diagram, but before that, write this problem. The question is determine the centroidal principal moment of inertia of the equal angle section 30 mm by 30 mm by 10 mm. That is, they've asked me just to find out the principal moment of inertia. That means here we will not only calculate IXX, IYY, but also we will calculate IUU and IVV. Okay, all these things. And also we have to find out the angle of inclination also, right? Angle of inclination tan theta. Another thing, the angle of inclination, the equation for that is given here. So I have not written here, so I will write in the whiteboard. That is the tan theta. But for sometimes we have to find out the angle of inclination, theta. Okay. So that also we have to find out. So here is the equal angle section. The sides are 30 mm, 30 mm, and thickness is 10 mm. It is the thickness is 10 mm. And this is the diagram. This is the diagram. So it is the sides, if you see, it's the angle section, L shape. The thickness is 10 mm each. G1, G2, these are the two CG distance or CG points. These are the CG points of these two different bodies. There are two rectangular section. One is horizontal, another is vertical. So G1 and G2, these are the two different points, the CG points. Sometimes the CG points will be given in the question, or sometimes we have to find out. So 30 mm, 30 mm vertical side and horizontal sides. XX and YY are the principal axis. CXX, if you see, CXX is the centroidal distance between the original XX axis and the X axis of the lower edge. Okay. So CXX and CYY. CXX is the centroidal distance of CG or from XX axis, and CYY is the CG distance of from YY axis. Here, or this diagram you will get. Okay. So all of you have to be ready with your calculator and take down this diagram properly, neatly. So first, so I hope all of you have uh, drawn this diagram. Now we will start the numericals. Okay. So here, practically in this diagram, this is type 1. This is type 1 question, first type. So here we have to find out the various items IXX, IYY, then CXX, CYY. Then we have to find out IUU, principal moment of inertia, all these things, and also angle theta. We have to find out all these things. So this question will be of 6 marks. So now we have, so edges are 30 mm and 30 mm. So I have divided this body into two different bodies, body 1, body 2. Body 1, body 2, okay? Because until unless we will divide this body, we will not be able to understand this thing, okay? And G1, G2 are the two CGs, they are already located, okay? So this G, we will take the centroid, the point of CG, we take as origin. Now for these diagrams, for these numericals in this chapter, you have to imagine this figure is located or situated in a graph paper. So the CG is the origin axis, 0, 0, it is origin. First quadrant, second quadrant, third quadrant, and fourth quadrant. First, second, third, and fourth. So the G1, it is located in fourth quadrant. G2, it is located in second quadrant. Okay. Many times we have to G1, G2, and write down. G1 is the CG of body 1. The location of G1 is given here. 4, -6. And G2 is CG of body 2. G2 is CG of body 2, that is, it is given -6, 9. So G1, you can see x coordinate positive, y coordinate negative, fourth quadrant, so 4, -6. And here, second quadrant, x negative, y positive, so -6, 9. It is given. Sometimes you have to find out also, okay? It is giving the question, sometimes you have to find out also. So then I will show you. The first solution, let us start. Okay, so now see here. First is step 1. So first we have to calculate the CX6 and C5, that is, determine the CG distance. Determine the CG distance from XX and YY. Determine the CG distance from XX and YY axis. Okay, we will determine this. Determine CG distance from XX and YY axis. So first we will calculate CXX and CYY. Okay, CX. This we have to find out first. So what is CXX? It is the CG distance of the whole body. See, this capital G point, it is not the CG of, let me make the screen up. This G point is not just the CG of this body or this body. It is the CG of the total compound body. Okay, so we have to find the location of this G, even if we are taking this as origin for this body at this base edge. Please tell Abhishek Kumar not to join. Roll number 107 is disturbing me. So CXX and CYY, we have to find out this location of CG. So what will be the formula, or what will be the thing? Now to find out the CG, what we will find out along CXX? So we will find out A1 to see here. CXX, it is in vertical direction, right? CXX is in vertical direction. See here. So A1x1 plus A2x2. We will take two diagrams. So what we learned in centimeters also to find out CG. CG, what we used to find out along y direction, we used to find out A1y1 plus A2y2 plus something like this, whole divided by sum of the ADR. So we take the moment of the areas to find out this CG distance of the total body along y-axis. This formula we have learned in strength of material. Here also we have to find out CG distance in y-y direction. Okay. Why I am replacing c-axis? Because these are the distances between two parallel x-axis axes, but it is in vertical direction. Okay. So a1 x1, yes. So obviously a1 x1 plus a2 x2. Here two diagrams are there. Divided by a1 plus a2. a1 x1 plus a2 x2 plus a1 plus a2. Okay. Okay. Now see a1 x1. a1 first a1 is what? This figure is a1. This figure is a2. I have divided this figure for your understanding. So a1 is the area of this diagram. So 30 into 10. Mark, see here. 30 mm by 10 mm. a1. 30 mm by 10 mm multiplied with x1. x1 in which direction? x1 is the CG distance, the CG of this rectangular body. CG. So 30 into 10 into if I calculate in vertical direction, so the CG will lie in the midpoint. So 10 by 2. 30 into 10 into 10 by 2. So 30 into 10, 10 by 2. Okay. So a1 into x1 for this one. So 30 into 10 into this half distance. Vertical height is 10. I am taking only this body. Vertical height 10. So 10 by 2 plus a2 into x2. I am coming to this figure. So now the area of this 20 here because 10 I have already taken. So here 20 into 10 into the height vertically we have to find out. So 10 from the, so I am calculating from the bottom. 10 plus 20 by 2. So this will be my a2 x2 by a1 plus a2. a1 is 300 plus 200. So we are calculating this distance from the base. See, from this edge. All of you please make it. Mark it. When we are calculating this distance, we will calculate from this edge. cxx. From base to top. Base to this. So for this body, see here. From base to this, so we are taking only this body, half distance of 10, 10 by 2. When we are talking of this body, I have to find out this distance. So 10 plus 20 by 2.
Sir, CXX is 11, sir.
Correct. CXS is 11 mm. Very good. CXS is 11 mm. Okay. Now, as I told you, for equal angle section, here you can write down for equal angle section. For equal angle section, CYY and CXS will be both same. CYY and CXS will be both same, right? But we know this thing because we have learned that trick. But for this is the first diagram, so let us calculate. Let me show you. It is coming same. In exam time, you will just do this if it is equal angle section. Okay. So CYY, let us calculate. Let us see that CXS is coming same. CYY. So here also, so A1, Y1. So CYY is the CD distance from this Y axis. This is X1. This is Y1. Okay. So CD distance, CYY is CD distance from this edge, from left side edge. So A1 Y1 plus A2 Y2 by A1 plus A2. A1 plus A2. Okay. So A1 Y1. So we are for this same for this body A1 So 30 into 10. So now we have to calculate distance from this edge. From this edge. So from this edge, this body will be 30 by 2 plus 30 into 10 into 30 by 2 plus this body A2 20 into 10. Oh, sorry. Here it's 30 by 2. Sorry. Here we have to subtract this part because this thickness is there. So 30 minus 10. 30 minus 10 by 2 for this body 1. So this is the y1 distance for body 1. This distance 30 length, 10 thickness into 30. Within this 30 we have this body na. So we have to subtract this. So 30 minus 10 by 2 plus 20 into 10 into 10 by 2 whole divided by 500. 300 plus 200. So here it is coming 11 mm. Cx is coming 11 mm. Okay.
স্যার বলছি স্যার
Here G1. হ্যাঁ বলো।
স্যার বলছি 30 - 10/2 ওই জায়গাটা একটু বলবেন।
এটা হচ্ছে দেখো 30 এর মধ্যে তো এই বডিটা আছে। উইদিন দিস 30 বডি এই 30 লেন্থের মধ্যে এইটুকু লেন্থ আছে। তো এইটুকু লেন্থ আমাকে বাদ দিতে হবে কেন আমাকে জাস্ট এদের ইটসেলফ খালি এই নিজস্ব যে লেন্থটা সেটা আমার বার করতে হবে। তো এটার মধ্যে যদি এটা চলে আসে তাহলে ভুল হচ্ছে। তাহলে 30 হ্যাঁ বলো।
স্যার বলছিলাম আপনি যদি ওই 30 - 10 করেন না, আপনি তো ওয়াই অ্যাক্সিস মানে যেটা ওই ওয়াই অ্যাক্সিসটা মানে কি বলবো পারপেন্ডিকুলার টু দা 30 এটা
ডিসটেন্স বার করতে।
হ্যাঁ ওইটা থেকে তো বেরাচ্ছে না। না হলে আপনি এটা ক্যালকুলেট করলে 11 আসছে না, এটা 8 আসছে।
ও আচ্ছা আচ্ছা এক মিনিট।
নিতে হবে
স্যার
নাহলে তো
স্যার ওটা তো মানে বটম থেকে
হ্যাঁ,
হবে ওটা, তাহলে 30/2 হবে তো ওটা।
হ্যাঁ নাহলে তো ওটা
ঠিক
বাদ
আছে,
হয়ে
ঠিক আছে।
যাচ্ছে।
ওটাই।
ঠিক আছে হ্যাঁ হ্যাঁ ঠিক আছে সরি 30/2 হবে ঠিক আছে। 30 into 10 30/2 প্লাস তাহলে 30/2 তাহলে এইটারই যা হাফ ডিস্টেন্স তাহলে along this direction so এর হাফ ডিস্টেন্স প্লাস 20 into 10 এটার হাফ ডিস্টেন্স। ওকে তো সব মিলে হলো 11 mm cxx 11 mm cyy 11 mm। এবার এখানে আমার সিজি গুলো দেওয়া আছে। ওকে তো হিয়ার সিজি গুলো দেওয়া আছে। এরপর it is step 1 the calculation of centroidal distance of this point G। এবার চলে আসো এবার আমাদের বার করতে হবে মোমেন্ট অফ ইনার্শিয়া স্টেপ 2। তাহলে cx এর cy এর ভ্যালু কিন্তু লাগবে লিখে দাও। এবার লেখো স্টেপ 2 step 2 calculation of moment of inertia okay so first is IXX moment of inertia about IXX okay আচ্ছা moment of inertia তে আমার টোটাল বডি moment of inertia IX মানে হচ্ছে moment of inertia of total body লিখে নাও তাহলে পরে বুঝতে পারবে। moment of inertia of total body of body 1 and 2 body 1 plus body 2 okay total moment of inertia of body 1 and body 2। so moment of inertia of body 1 তাহলে হচ্ছে IXX of body 1 plus IXX of body 2 IXX of body 1 plus IXX of body 2 ঠিক আছে। দেখো ফার্স্ট বডিটা কি হবে প্রথম হবে BD কিউব বাই 12 রেক্ট্যাঙ্গুলার আছে রেক্ট্যাঙ্গুলার আচ্ছা আচ্ছা, এবার হচ্ছে দেখো, ঠিক আছে, ইন্ডিভিজুয়াল বডি, তাহলে বিডি কিউব বাই 12 হচ্ছে ফর দিস রেক্টাঙ্গুলার বডি, তার মোমেন্ট অফ ইনার্শিয়া বার করছি আস্তে আস্তে, ভ্যালু পরে লিখবো, বিডি কিউব বাই 12 প্লাস কি করেছিলাম, এ ইনটু এক্স বার স্কয়ার, কারেক্ট, ফর বডি 1 প্লাস আবার body 2 bd cube by 12 plus a into x bar square for body 2, body 1 and body 2. এখানে আমি কি ইউজ করছি, প্যারালাল অ্যাক্সিস থিওরেম, যারা ভুলে গেল একটু দেখে নেবে, those who have forgotten they will go to study the material book, parallel access theorem. It is very easy but it is very much important. As a civil engineer you have to remember this thing, parallel access theorem. So come here, so 40 for this come, so x bar, see x bar, so come for first come in this part, bd cube by 12. What is bd cube by 12? B is 30 for body 1, b 30, b 10.
ওটা y বার হবে না, ix, হ্যালো
হ্যাঁ বলো,
স্যার বলছি ix এ ওটা a y বার স্কয়ার হবে না?
অ্যাকচুয়ালি দেখো y এটা কোন ডিসটেন্সে নিয়েছি আমরা, আচ্ছা আমি তো ওই x ডিসটেন্সেই নেব, মানে এই ডিসটেন্সেই নেব, ঠিক আছে, তাহলে y বার করে দাও, y বার করে দাও। অ্যাকচুয়ালি আমাকে জাস্ট বুঝতে হবে আমি ভার্টিক্যাল হাইটের ডিফারেন্সটা নেব, ঠিক আছে, ভার্টিক্যাল হাইটের
ইয়েস স্যার, ওকে ওকে।
তাই করো y বার, ঠিক আছে, y বার, তার মানে ভার্টিক্যাল ডিসটেন্স নেই। তাহলে আগে একটা একটা করে দেখি, কেন এটাই মোস্ট ক্রিটিক্যাল জায়গা, দ্য মোস্ট ক্রিটিক্যাল পার্ট অফ দিস প্রবলেম। Others are formula based, here we have to apply some brain. The first is bd cube by 12, b is 30, d is 10, bd cube by 12 plus area, so b 30 10 cube, so bd cube by 12 plus area 300 into y bar distance. So y bar distance is basically the cg distance. Please make sure the cg distance between this whole body, so y bar will be what, cg distance of the whole body minus cg distance of this body. Okay, so let me show you in the screen, let me show you. So for example, this is my red mark, okay, so the red mark is the cg distance of this body, so this one will be this distance, y bar. So first body, for first body y bar will be the cg distance of this body plus this whole body, এই ডিসটেন্সটা হলো y bar. Understand this, it is very very important. So therefore how much it will be, total is 11, cxx is 11, so cxx minus this 10 by 2 whole square, so bd cube by 12 plus a into y bar square, y bar is the this gap, cg of the whole body minus cg of this body, this one plus, now for body 2, for this body bd cube by 12, b is 10, b bd cube by 12, b into d cube by 12, obviously 20 because this is already taken, we will take this part only, this part, so bd cube by 12 plus a is 200 into, similarly here also this distance, so that means for this body this is the cg distance, see this is the y bar distance for this body, then cg of this body and cg of the whole body, understood, cg of this body plus cg of whole body. Okay, so how much it will be, now cg of this body you can find out, so 10 plus 20 by 2, this is the top, because we are calculating from base only, okay, whatever value we will calculate from the base. So this body is 20/2. Only this rectangular vertical 20/2 plus 10 mm minus CXX. So this is the thing. So let us so we are calculating these distances in vertical direction. Okay, very important. So slowly you have to take time and calculate. So first body 30, this one, it will be a huge number. It will be huge big number. This is a huge big number. Slowly calculate. One important trick I am telling you, you have to add this. First you calculate this part, then you calculate this part. Then it will be easy for you. First you calculate the left part, then you calculate the right.
Sir,
বলো।
sir, 36,166.66 millimeter to be 4.
36,166.6, right, ঠিক আছে। So it is coming 36,166.67 millimeter. Always remember the unit of moment of inertia. Many students do forget this thing. This is a trick. Always remember the moment of inertia. The unit is mm to the power 4 or length to the power 4. Okay. So 36,166. If you feel, you can make it round off. So you can make 37,000 also, whatever you feel. Okay. During the calculation time, if you want to make that one trick I'm telling you, if you want to make it more easy for calculation, you can round off to a whole number or keep it same. Or you can keep it same. So similarly, IIESTs this one. So for equal angle section, I told you this will be same for IIY. In order to calculate IIY, we will follow the same method only in x direction. These distances we have calculated in y direction. So IIESTs, IIY will be same. So now we will calculate step 3. Step 3. Calculation of IXY, calculation of IXY, IUU, IVV, all these things, and angle theta. Calculation of IXY, IUU, and IVV, and angle theta. এটা করে দিলে আমাদের হয়ে যাবে পরের দিন নেক্সট উইক অলসো। So IXY product of inertia দেখো, see product of inertia will be, see here. So we will first multiply A1, first body A1 x1 y1 plus A2 x2 y2, where x1 is the coordinate of G1 and G2. Where x1 is the coordinate of G1 and G2. G1 was coming 4, -6. This is basically x1 y1. This is the coordinate -6, 9, x2 y2. So x1 y1 are the coordinates of the respective CGs of the body given. Okay, 4, -6, -6, 9. So here we'll multiply. So we are multiplying. So that is a product of inertia. Okay. That is the product of inertia. So we were multiplying area with respective body area into their coordinates. So for this thing, first body 300, 300 into 4 into minus. We have to take the sign also. We have to take the sign also. So the product of inertia is IXY. IXY. The product of inertia A1 X1 Y1 plus A2 X2 Y2. So it is coming minus 18,000. If you make it, you can go minus 18,000 millimeter to the power 4 IXY. Okay. So now find out angle theta. The formula for angle theta is angle 2 theta equals to 2 IXY by IYY minus IXX. See here, to find out the angle theta, angle of inclination tan 2 theta is equals to 2 IXY by IYY minus IXX. Write this down, we have not written this. So 2 IXY, so 2 into minus 18,000 divided by IY by IXX then. So the denominator is coming 0. So the denominator is coming 0 since IY by IXX. So it is indefinite, or rather I should not write this. It should be indefinite because denominator is 0. So the answer cannot be found out. So indefinite. So therefore weight is indefinite. So we can make it. So this happens when tan to theta is 90 degree. So therefore theta is 90. Sorry, theta 1. So first angle is 45 degree. Second angle is 135. 90 plus 45, 135 degrees. There will be two angles. One is the angle of inclination with XX, that is theta 1, 45, and the angle of inclination with XS with VV. Okay, if these are two mutually perpendicular, one is যদি একটা 45 degree হলো আর একটা হবে 90 plus 45 because they are two mutually perpendicular. If I find the angle from the same axis, if I find the angle counterclockwise with respect to x-axis.
স্যার
বলো
স্যার স্যার বলছি এখানে G1 G2 টা 4 আর 6 টা কি করে হলো একবার বলে দেবেন
এটা
স্যার যেন।
এটা দেওয়া আছে, এটা দেওয়া আছে, ঠিক আছে। অন্য কোশ্চেনে যখন আমরা বার করব আমি বার করে দেব। নেক্সট দিন আই উইল ডু আনাদার প্রবলেম, দেয়ার আই উইল ফাইন্ড আউট দ্য সিজি, ঠিক আছে। এখানে দেওয়া ছিল।
স্যার
হ্যাঁ বলো।
স্যার বলছিলাম ওই 10 + 20/2 - CXX যেটা করেছেন না বোর্ডে, আচ্ছা আমাকে তো তাহলে ওকে মানে সেটা করার জন্য আমাকে জানতে হবে যে মানে G2 টা যে ক্যাপিটাল জি এর উপরে আছে সেটা তো আমাকে জানতে
এটা
হবে, নইলে
হ্যাঁ
তো।
এই ডায়াগ্রাম দেওয়া থাকবে, ইয়েস অল দিস উইল বি গিভেন দ্য ডায়াগ্রাম। যদি আমি না জানি তাহলে করা খুব মুশকিল।
হ্যাঁ, কেননা ওটা যদি নিচে থাকতো সেক্ষেত্রে তো মানে মাইনাস হতো না, তাই না?
Yes, absolutely. If this will be given the diagram, if diagram না দেওয়া থাকে, it is very difficult to understand.
আর একটা হচ্ছে স্যার সবকিছু এখানে ক্যালকুলেশনটা বেস থেকে হচ্ছে, তাই তো? মানে আইএক্সএস
হ্যাঁ
বা
সব হ্যাঁ
আইওয়াই।
বেস থেকে করতে হবে।
ঠিক আছে।
সবসময় মোমেন্ট অফ ইনার্শিয়া চ্যাপ্টারে যাবে, সেকেন্ড ইয়ারে দেখবে সব বেস থেকে আমরা ক্যালকুলেশন করি।
হ্যাঁ স্যার।
So here we have found out the principal, the product of inertia IXY. I have found out the angle theta. There are two angles. If one angle is 45 with respect to x-axis, another angle, that is this is angle of inclination of UU, this is angle of inclination of VV. One is 45, another is 135. আর একটা বাকি আছে, that is calculation of IUU IVV. So therefore you just calculate IUU. So IXX plus IYY by 2 by 2 whole square plus IX whole square. If you find out IU, then you can find out IGV using this trick. So IU is coming around 18167 mm to the power 4. So the principal moment of inertia IU is 18167 and IGV is coming 5433. 5434 minutes. Just check this. You will get the answer. Answer. Copy this down, then I will take the attendance. ঠিক আছে লিখে নাও next day on Monday we will start the class sharp at 9 am
স্যার
9
এক মিনিট স্যার।
হ্যাঁ লিখে নাও আস্তে আস্তে করুন
হ্যাঁ স্যার 18166.67 আর একটা হচ্ছে 541666.16।
হ্যাঁ yes yes
স্যার হয়েছে স্যার।
আচ্ছা ঠিক আছে তাহলে আমি এবার অ্যাটেন্ডেন্সটা নিয়ে নিই